So hi. So basically, I'm here to introduce two papers that is very kind of related to our project, and where I'm going to discuss the pros and cons of them comparing to our solution, and what's their key feature and how did they do it. So the first one is called I kind of don't remember the name. They have a site inspection drone system that is like real time robust drone system for site inspection and violation detection. And they can also have remote inspection capability from control station or nearby location. That is also very similar with our project, which we can get feedbacks and protocol the drone from our users and device too. And that one is limited to 20 minutes flight due to payload and power consumption. So so the key feature of that is they have a integrated workflow with municipal database. So the system is uniquely designed to integrate seamlessly with a municipality database. So that one allows for very efficient scheduling for inspection and ensures the drone is equipped with the latest information regarding location and building code. So that one is more like we have you have like a very comprehensive database, because that one is for site inspection. So you need to, so for example, like, this place just got that building, so they will upload that, and your database is always the newest. So the key feature for me, the most interesting part, is that the drone is always connected to the most up-to-date database for the current site, the part of site that is inspecting. So basically, they did their experiment in Dubai Internet City. It's just an outdoor area. So they first have like a mock-up construction site. They have which was created by the competition organizer. They have like the paper the author mentioned. They had a competition back then. It was kind of for the competition first. With they have the deliverable violation embedded to test the system's detection capability, and they also have the part for drone operation. So it started from designated takeoff position, autonomously navigated to the inspection site, and follow a series of predefined GPS waypoints. So during this process, it collects images for offline 3D map reconstruction and online violation detection. And basically, trying to they analyze the data collection, the onboard GPS unit recorded the position and the trajectory followed during inspection was documented. And then they also have the violation detection. The online detected violation were reported through the web interface. For example, a violation such as like existence of worker out of working time could be visualized and verified by inspection officer. And they also have 3D model reconstruction. They use the image collected during the inspection, and they can build a 3D model based on that. So so basically, they trying to see evaluate the path of the drone, whether if the trajectory that they trying to evaluate if it can detect violation, if it can construct a 3D reconstruction quality. They all evaluated that. So for me, the pros of that, I basically already introduced. The cons of that, for me, first of all, the author mentioned the drone can only last for 20 minutes flight during inspection. That is largely due to the tons of sensors that it's using. They have IR, they have LiDAR, they have tons of other new stuff so that they can do the test during daytime or the dark place like nighttime. But it can only last for 20 minutes. To honestly, I think 20 minutes it's kind of short if you are using it to do site inspection. Imagine it's site inspection. This is like tons of. It's like 5 miles, 5 miles this place, 5 mile that place. I don't think 20 minutes is kind of enough for our project, because we use a very lightweight, so we only use camera. I trained the machine learning model that only based on the pure vision solution, which is just the RGB camera, which make it last way much longer than 20 minutes, at least from Peter said. And it is primarily for construction site, which is it's kind of not very versatile for other application. Imagine that it can only do construction site. But in our project, basically, it can inspect any source of vehicles and other stuff that need to detect damages or need to have maintenance. You can do it on car, that is currently our demo will be given it's about cars, inspect cars if they have scratch or dent. And we can also in the future we can have the inspection towards plane and tons of cool cars and other stuff, boat, all of the vehicles. And for the second paper is the one that is for aerial vehicle via the sampling based sequential optimization. That one is mainly about path planning based on as well heuristic path planning. This author spent a lot of time to analyze in the paper to say how did they design the algorithm for the path planning and how to be heuristic, something like that. And that one is also for aerial vehicle. This is the reason why I look up this one, because our object, our goal is to inspect all kinds of vehicles, and this one also talks about the aerial vehicles, which is also in our area. And okay, I'll introduce this paper along with their experiment. So basically, they have a bridge inspection case study. So they have the bridge to represent a solid structure type, and they also have a data representation. So the bridge is modeled using a point cloud generated by 3D mapping service, representing the bridge as a solid structure. And the paper also discussed how the system can handle bridge inspection, including steps like point cloud sampling, segmentation, and how do they optimize the path based on that. And in the end, they will have visualization. So the inspection of path for different parts of the bridge can be visualized and discussed, like the front, the back, the sides, this side, that side, like that. The second is the power pylon inspection case study. So that one is more kind of to so the power pylon is an example of open frame structure. Unlike the bridge, the power pylon's open frame design exposes both outer interface and inner structure, so that makes the estimation of normal vectors and modeling kind of challenging. And they have the path is planning and inspection on that is to handle these challenges like very detailed, including the use of convex hull extraction, mesh generation, and point sampling for mesh. That is way more complicated than the first one for me, according from this perspective, from the because they do not use the 3D model just as a like how to do the like what path you need to go. That also so this one also uses to have different tons of dots and that to generate a mesh to order, because this drone is designed in order to prevent in order to have like aerial vehicle inspection. So you don't want it to be like hit the vehicle, don't you? So that one also uses that. So they have specific parameters such as voxel size for downsampling, safety distance, maximal inspection distance, sensor incidence angle limitation. They have much more safety measures comparing to the first project. The paper presents the inspection path planning result for the power pylon, demonstrating the system's ability to handle complex open frame structure. So for me, the pros of that is like they use very comprehensive path planning, and they spend a lot of time to how to have the heuristic power planning for aerial vehicle addressing complex structure like bridges and power pylons. And they also have put many efforts into safety consideration. They have like constructing a convex hull and considering the collision avoidance through normal vector estimation. The method prioritize safety, which is very critical for autonomous drone inspection. And currently, our project we don't have safety consideration now. We currently only have a pre-trained model to work around the pre-trained model, and the drone will estimate the size of the vehicle and then go around it, and using the pre-trained model to see if there's any place that need to have maintenance. So the cons of this paper is that it is more heavily dependent on the quality of 3D model. And so imagine this will only work if you, for example, you are inspecting a plane. If you don't have like a very accurate, precise 3D model for the plane, there is no way you can do that. So this heavily based on that. But once you have the model, it can perform very precise and very accurate and very heuristic path planning based on the model. And it is very limited by the computational resource. Although efficient, the method's performance is still contingent on the computational capability of the hardware used. They use Intel IT CPU in the study, but from the it barely meets the standard, the expectation of the author, but it's not very ideal. But even that, they still use Intel i7. So it's heavily dependent on computational resources, and but from comparing to our study is basically used because the model is pre-trained. There's basically no computational place needed in our project. This is also they are all pre-trained. Although my computer suffers a lot from the training, but it's all pre-trained. It's just like weighted model. And we have the Coral card to speed up the calculation, so the response time wouldn't be a problem for our project. And that's pretty much these two paper talks about. And so for open research question is that whether do we need to, is it necessary to have like a have artificial intelligence involved during the inspection? For example, our group, we have the machine learning pre-trained model for that, but I remember some papers I saw they use artificial intelligence to like reinforce the learning based on the inspecting during the inspecting. And I'm not sure if that is needed. And I'm kind of I'm also kind of not very sure if like 3D model is needed for is necessary for vehicle inspection. Like I kind of get it if the aerial vehicle you use it to avoid collision, but from our solution we didn't use that. We think that we would just keep away from the vehicle for like we have like 5 feet away from the vehicle, and then we do a circle. There's no way you can have a collision if you're doing that. So I am kind of shaky about that, whether that is needed.